All right, welcome back. Let's do an example of linear approximations. Remember that we had that f of x was approximately f of a plus f prime of a times x minus a. And this side over here was called the local linearization. But it's the linear function that approximates f. So here's an example of it. Suppose f of x is 1 over x, and we're going to approximate f of, 3.02. Okay, so the exact value of this is just 1 over 3.02, and we want an approximation to that. So we need to know about the derivative here. That'll be minus 1 all over x squared. We'll need that for this formula up here. But then the approximation is pretty easy because, in terms of the notation above, by the way, we're using a is equal to 3 and x equal to 3.02. All right. So the thing we're trying to approximate is 3.02. And by this formula up above, it's f at 3 plus f prime at 3 all times x, 3.02, minus a, which is 3. So here we get 1 over 3. The derivative is minus 1 over x squared, so 3 squared. And then we have a 0.02. All right, you can do this by hand, or you can put it on a calculator, and the answer is 0.331111, as many ones as you want. All right, so that's the approximation. All right, here's the second variant of this problem. And remember, it depends on this formula, that the delta f of x was approximately f prime at a times the delta x. Okay, so here's an example of that. So suppose f of x is x squared, and then let's estimate delta f, where we're looking at f of 3.02 minus f of 3. Okay, so in this setup, here, the x is 3.02 again, and the a is 3. So the delta x will be 3.02 minus 3, so just a 0.02. And using our formula here, then, we get delta f is approximately the derivative at a. Remember, the derivative was minus 1 over x squared. We plug in a, that is 3, so we get that, times the delta x, which is 0.02. So you can put that on your calculator, and if you do, you get 0.36. So that's roughly how much f will change if you change x by 0.02. All right, those are the examples. Ciao.